So good morning everyone, I am Arvin J. Emilian. For today, I'll show to you how to solve item number 61 under exercises 1.2. So let's proceed. So for step number 1, of course, we will write down the given. So number 61, we have the Greek letter for lambda minus 2x plus y is equal to 0. And then we have x plus lambda again minus 2 is equal to 0. So for our step 2, we'll just write down the augmented matrix. Augmented matrix. So on this part, we will just write down all the coefficients of x and y. So first we have lambda minus 2 on the first row, 1, and then 0. And then in the second row, we will have 1, lambda minus 2, and 0. So for step 3, we will just have to interchange the row 1 and row 2. Row 1 to row 2. So now we will have 1, lambda minus 2 and 0 for row 1. Now we will have lambda minus 2, 1, and 0 for row 2. So now let's proceed to step 4. So for this step, we're just going to apply this equation. So we have negative lambda minus 2 multiplied by r1 plus r2 for us to get the values of the second row. So now we will have 1 on the first row, lambda minus 2, and 0. Same as the recent one. And then for row 2, we will now have 0, negative lambda minus 2 squared, plus 1, and 0. So for step 5, we will just extract negative lambda minus 2 squared plus 1. So now we will have first the row 1, which will remain the same. 1 lambda minus 2 and then 0. So for row 2, we will have 0 lambda squared. Oh, I'm sorry, that's lambda, not x. Minus 4 lambda plus 3. Just an error on writing, sorry. So, and 0. So now we'll have that. For step 6, so there, I will just revise it because I got an error on typing. So that's lambda. We're going to factor lambda squared minus 4 lambda plus 3. So it's just equal to lambda minus 3 multiplied by lambda minus 1. So now we will have this. For second row, we'll have 0, lambda minus 3, lambda minus 1, and 0. So for step 7, we are going to write down the associated equivalent the associated equivalent systems of linear equation. So now we have x plus lambda minus 2y is equal to 0. And then for second one, we have lambda minus 3 multiplied by lambda minus 1, y is equal to 0. So for the final step, which is the step 8, now we should consider this rule: y should not be equal to 0, for us to prove that the system of linear equation is non-trivial. So now we have lambda minus 3 and lambda minus 1. We're gonna equate both to 0. So now we will have lambda is equal to 3, or lambda is equal to 1. So it means that the system is non-trivial when the lambda is equal to 3 and lambda is equal to 1. Is equal to 1. I think that could be the end of the video. Thank you so much for watching. I hope you've learned something from what I've showed you about finding the values of lambda, such that the homogeneous system of linear equations will have non-trivial solutions.